Welcome to the Building Science Podcast. Welcome to the Building Science Podcast.
Bringing the human factor to construction, design, and architecture. Brought to you by Positive Energy in Austin, Texas.
Wait, I'm not ready. Are we Okay, hello and welcome everybody. Welcome back to the Building Science Podcast. I'm Christoph Irwin, and I'm pleased to announce that today I have with us in the studio here Dr. Scrimshaw Hatcheck of Energy Vanguard in Atlanta, also known as Dr. Allison Bales. Say hello, Allison.
Hello, Allison.
Hand me $20, Allison, if you're following my instructions. Okay, so Allison's here today, and we have decided to speak to you guys about a very important human factor that's inside buildings. It's around you right now, I'm almost certain, unless you're listening to this while you're underwater, and it's air. So we're going to be talking to you today about ventilation, and I'm going to do a quick intro to get you there. So as you know, you breathe a lot of air. You breathe hundreds of pounds of air a day, and you hope that there's no negative health outcomes from doing that. And we also hope that there's no negative outcomes for the building itself from the air that's in, around, and inside of the building cavities. So the basics, like the high points of having good indoor air quality, would be to separate the indoor air from the outdoor air. And you can chime in or kibitz anytime you want here, Allison.
Sure.
To separate the indoor air from the outdoor air, that's the environmental separator. That is the job of your enclosure, and specifically the air control layer. And probably most of you that are listening have heard other podcasts. We've talked about both of those things, environmental separation and air control. The next thing you want to do is you want to filter the air that's in the building. You want to capture any particles that come in, because even if your air barrier is perfect, you had to open the door to get in there. And there's a chance that some pollutants got in, and many things that we do inside our homes generate pollutants, so we want to filter those out. We want to capture those. And so speaking of pollutants, I think one of the biggest ones in our humid climate, and Atlanta has some humidity, right, Allison?
Oh, we have a little bit.
A little bit of humidity. So humidity is considered a pollutant, and that means that we handle that two ways. One is we have a system to control indoor humidity to reduce that pollutant. And even better than having to pay to dehumidify your space would be if you are doing something that is going to generate a pollutant, whether it's humidity or a particle. Think cooking or showering, doing laundry, things like that. The best way to control that is to get it outside. So those are kind of like the big three that lead up to the next one, which is bringing in fresh air from the outside. And then we're going to open up our conversation with Allison about that. So bringing in fresh air from the outside, what's the first thing that comes up for you when we think about that? What's the most important thing?
The first thing, the most important, well, there's a lot of important things, but I think what we were going to focus on in this podcast is deciding how much outside air to bring in, the rate, the ventilation rate.
Okay.
So you want
keep going on that. Yes,
yeah.
That sounds fine.
So there's a lot of things to decide there. Number one, there's a ventilation standard called ASHRAE 62.2. It is the residential ventilation standard for high-rise and low-rise now. It used to be
So
just be
high-rise.
low-rise, but now it includes high-rise. And the residential ventilation standard, ASHRAE 62.2, may be the way that you decide on what rate that you design a ventilation system.
So by rate, what do you mean?
How many cubic feet per minute of airflow you're going to bring in from outdoors.
Okay.
And if that's going to be continuous or intermittent, and where it's going to be put and all that. So,
Okay. So the rate is just the amount, or rate is the rate. It's how
Right.
fast it's coming in.
Yep. How much air you bring in per whatever unit of time.
Okay, got it.
Usually CFM, cubic feet per minute.
Cubic feet per minute. Okay.
So there is a standard out there, ASHRAE 62.2. Now, do you need to use ASHRAE 62.2? Maybe not.
Is it in the codes?
It is mentioned in some codes. It's actually not in the ICC, the international. Well, it's not in the IRC or the IECC.
Mm-hmm.
It is the stuff that's in there is based on what's in the ASHRAE 62.2.
Got
as
it.
far as I understand.
I remember that.
So the first thing is you need to know what you're subject to. You know, if you're building a house or remodeling a house and you have to put ventilation in, do you have to put it in for the code? So you need to know what your code says.
Mm-hmm.
And if you're going for certification in a program like Energy Star, you do what they say. And theirs is currently based on the ASHRAE 6222, the 2010 version, 2010 version. And the 2016 version is about to come out. ASHRAE 6222, the standard, is updated every 3 years. And so the 2010 version, the 2013 version is out. The 2016 version is about to come out. And so if you are subject to a building code and your building code requires ventilation, then you do what they say in the code. If your building code does not say anything about ventilation, you don't have to put in ventilation, but if you're building an airtight house, and we want you to build an airtight house, then you need to have some kind of ventilation.
Right,
so if your code doesn't say it and you're not building to a program that requires certain design parameters, then you can do what you want. And
you can have the outcomes that might or probably will come along with that.
Yeah.
I know our code doesn't specify whether it's exhaust ventilation, supply ventilation, or balanced ventilation. But I also know it's a hot, humid climate, so exhaust ventilation is not a good strategy here.
Right.
Because, there's the basic rule in ventilation that every CFM of air you take out of a building, you're adding a CFM in from somewhere, and vice versa. If you supply air from somewhere, it's going to go out and or slightly pressurized, right?
Yep. And so if you excuse me.
Does 62.2 go into the distinction between exhaust, supply?
It does talk about that, but the rate is the same. In ASHRAE 62.2, the rate is the same no matter which type of ventilation you use, which strategy, exhaust only, supply only, or balanced.
Wow.
Let's talk about the rates, which is what we want to focus on in this podcast.
Yes.
So let's start with ASHRAE 62.2 because that is what a lot of it's based on. ASHRAE 62.2, the 2010 version, let's start with that one.
Okay.
And this is a simplified explanation. There's other details in the standard, but we'll give you the simplified version here. The 2010 version says that you need to put 1 CFM per 100 square feet into the building, into the home, plus 7.5 CFM per person. And a person is not a person, really. A person is the number of bedrooms plus, the number of people in the house is defined as the number of bedrooms plus 1.
Okay.
So you assume 2 people in the master and then 1 person in each other bedroom, and that's how you decide how many people to add air for.
Interesting. So the ventilation rate is actually based on a guess or an approximation of how many people are in the building.
Yep. And it's not the actual number of people living in the house, which maybe it should be, but it's based on a guess based on the number of bedrooms. Because if you're doing new homes, especially if you're doing new production homes, new spec homes, and you don't know how many people are actually going to live in the house, you have to have a method for deciding how much ventilation to put in.
So let me just make some numbers on it. So you just said, I'm going to say that our example house for this podcast is 2,500 square foot, and it's a 3-bedroom. So then we'd have 25 CFM based on the square footage.
Yep.
And then 3 bedrooms, so we do 4 people, 7.5 each. That's 30. So that's 55 CFM total. Yep. And that's based on the 2010 standard.
Yes.
Okay.
Yeah. So
and that's continuous. 55
that's
cubic
55
feet per minute
CFM continuous.
air
24 hours a day, 7 days a week.
Filtered air coming in from the outside.
Yep. So if you run half an hour out of each hour instead of continuously, then you'd have to double that rate to 110 CFM.
And if you
for
do
the 30 minutes that it
15
runs.
minutes out of every hour, you quadruple that rate.
Yep.
So
you have to bump up the rate if you decrease the amount of time that you run, if you run intermittently.
Right. Yeah. I know I've seen a lot of air cyclers, which is a device that turns on the central air handler for a certain period of time every hour to accomplish ventilation. And it's funny because I've seen them in roughly a 2,500 square foot house, a 3-bedroom, set to 15 minutes. And so I think, okay, so I have roughly 50 CFM of air that's needed continuously, but this is set for 15 minutes of ventilation, so I got to quadruple that. So I need 200 CFM, and then it's connected to like a 4-inch duct going to the outside, maybe a 6-inch duct. So that's another part of the calculation, I guess, would be like, what is the odds of getting 200 CFM through a 4-inch duct? Okay, so that was the 2010 standard, and 2013 is
So in
changing.
2013, they changed one part of it. It's still the 7.5 CFM per person,
Okay.
but the square footage part changed. Instead of 1 CFM per 100 square feet, it is now 3 CFM per 100 square feet.
So they tripled it.
They tripled it.
And so what's the rationale behind that? Do you have a sense of that?
The rationale is that before 2013, they said it was 1 CFM per 100 square feet, but well, they said it was really 3 CFM per 100 square feet, that part. But everybody got a 2 CFM per 100 square foot default infiltration credit.
Oh, okay.
They said that you didn't really have to do 3 CFM per 100 square feet because you're probably getting 2 CFM per 100 square feet from just air leakage.
So you're getting 2 CFM per square foot infiltration credit,
Yeah.
although it is not filtered.
Yeah. So in 2013, in that version, the committee said, well, houses are getting tighter, a lot more blower door tests are happening, and let's just drop that default infiltration credit and go up to 3 CFM per 100 square feet. So what does that do to the ventilation rate needed for that 2,500 square foot 3-bedroom house?
It went up. So instead of 25 for the house and 30 for the occupants, I have 75 for the house and 30 for, I have 105.
Yep. It
So
goes
I went
from
from 55 to 105.
Yeah. So it almost doubles.
And then
Now-
if I do it 15 minutes an hour, I need 420 CFM for 15 minutes.
Yep.
Wow.
Yep. And before we get into the ramifications of that increase, let's back up 1 second because I mentioned blower doors here. A blower door is a device that allows you to measure the infiltration rate, the air leakage in the house. And if the house has a high enough infiltration rate, the standard has a lot of complexity in there about this, and you can get credit for the infiltration rate if you do a blower door test.
Interesting.
The problem is if you're building a new house and you're passing a code that has a decent requirement for air leakage, if it's passing the code requirement for air leakage, you're probably not going to get much back on that. So you're still going to have to do close to the 3 CFM per 100 square feet on that part.
Interesting. So either you don't get inspected, don't do the blower door, and you have to do a lot of ventilation. So, I mean, the only way to have the blower door test lower the amount of ventilation would be if you proved that you had a very leaky house.
Yeah.
And then in that case, it wouldn't be code compliant.
Yeah.
So why would you be proving it?
Yeah. So, well, if you're doing existing homes, like in weatherization,
And you're not doing a remodel.
yeah, so this increase really affected the weatherization folks because they were always kind of living on the edge anyway and trying to decide whether they should do more air sealing and have to put in ventilation system or stop their air sealing at a certain point so they didn't have to put in extra ventilation and increase the cost because they're working with very limited budgets and trying to fix affordable housing and having to deal with all these trade-offs. So their issues are different in dealing with the standard.
Absolutely.
In new construction, requirements for blower door tests and meeting certain thresholds for air leakage have really started appearing in a lot of states in the last 5 years. And Georgia, where I live, was the first state to adopt a mandatory blower door test with a threshold.
Wow.
So
Did you have anything to do with that?
just a tiny little bit. A guy named Mike Barsick was one of the main guys behind that. He works at Southface. Really great guy. Anyway, so in Georgia, we've had the blower door test required for 5 years now. Our threshold is relatively high, 7 ACH 50. So we probably could get some of that 3 CFM per 100 square feet back if a builder just passed that, that 7 ACH 50. But
What climate zone is that? Climate zone
We're in
2?
climate zone 3.
3.
Well, Georgia, the state of Georgia has climate zones 2, 3, and 4.
Okay, but Atlanta's in 3.
Atlanta's in 3. So with the 2012 and 2015 IECC, the air leakage requirement dropped significantly. With the 2009 IECC, the whole country was 7 ACH 50 or you had to come in at 7 ACH 50 or less.
Right.
With the 2012 and 2015, climate zones 1 and 2 go to 5 ACH 50 or less. Climate zones 3 all the way up to 8 go down to 3 ACH 50. So in Atlanta, if we ever get on the 2012 or 2015, we're going to have to go from 7 ACH 50 all the way down to 3 ACH 50.
Mm-hmm. Okay, and that's the thinking, the rationale behind getting rid of the infiltration credit and saying you have to ventilate it in.
And getting rid of the infiltration credit means if we're required to meet 3 ACH 50 for our air leakage, then we're not going to get much, if any, credit. So we're going to have to do the 3 CFM 50.
So
3
105 cubic feet per minute continuous in a residence in a 2,500 square foot house. Wow.
Yeah. And so what that does when you add extra ventilation air is it means you have to do more conditioning because you're almost doubling the amount of outdoor air you're bringing
absolutely.
in. You bring in more humidity.
Yeah, I was going to calculate that, but
yeah, I mean, as we're making homes tighter and better insulated, and all of a sudden you add all this extra humidity, now your air conditioning system can't handle the latent load from that. So it's getting to the point now where we almost have to have supplemental dehumidification anyway. With higher ventilation requirements, it's definitely a given.
Yeah, and you've heard us say on this podcast before that almost was a while ago, and we're already there. But there are cases where I guess it would depend. I'm just looking right now. If I say that Atlanta's at 300 feet above sea level, 100 degrees outside, and a summertime relative humidity, that's 117 grains per pound.
We're actually at 1,000 feet, but
you're higher than us. Wow.
Yeah, we're 1,000.
We're at like 500 to 700 here. Okay, so that's a tangent, but it's going to be pounds of water coming in per day. I mean, we can calculate that and tell you guys later in the podcast.
So the 2013 version means that we have to, if you're putting your ventilation system in and designing it to the 2013 version, it's almost double the amount of outdoor air you're bringing in compared to the 2010 version. So if
that's got to raise some eyebrows. My eyebrows are raised.
And the other thing is that there's no epidemiological data showing that there's a real benefit to doing that. We know that there are some drawbacks to doing that: the energy penalty and the humidity penalty in humid climates.
Yeah.
And also in really cold climates, bringing all that outdoor air in, and when it's 10 below zero or something, that's an issue.
Huge energy penalty, in that situation.
And comfort as well. So if you don't have to do ASHRAE 62.2 2013, you can decide what you want to do if you.
And it's not code anywhere yet right now.
And that's not in the code. Speaking of code, well, let's talk about what the code is. The 2018 IRC will include the ventilation rate that's the same as the 2010 ASHRAE 62.2. Now we're throwing around a lot of dates and initials here.
And numbers, yes.
So, but the 2018 IECC will say that you have to put in a ventilation system that supplies 7.5 CFM per person and 1 CFM per 100 square feet.
Okay, so it's back to that.
Yep.
That's what those of us in the industry consider normal.
Yeah.
Basically.
I think that's a good rate, and it doesn't say anything about the ventilation strategy that you're using. So there's this guy named Joe Stiebrick.
Never heard of him.
Never heard of him?
Everybody's heard of him.
Professor Josef L. Stiebrick.
Yes.
Dr. Josef L. Stiebrick. Joe Stiebrick is a building scientist, one of the founders and principals of Building Science Corporation based in Massachusetts. And he's on the ASHRAE 62.2 committee again. He was off it for a while, but he's back on it now. And he is trying to get them not only to reduce the rate, he was one of the main proponents of getting the 2018 International Residential Code to adopt the lower number of 1 CFM per 100 square feet. But he's also...
And that just happened, right?
That just happened this fall. Yeah.
Mm-hmm. That's big
and
news.
he's also been working on trying to get the codes and ASHRAE 62.2 to recognize the differences between different ventilation strategies. Now, exhaust only is absolutely the cheapest ventilation system that you can put in, because you've already got bath fans and a range hood in the house. You put some controls on them, and there's your ventilation system. The problem is that you don't know where the air is coming from. If you got an attached garage, you're probably getting some from the garage with
and
all
it's
the nasty
undoubtedly
stuff out
coming from a building cavity of some sort, which is not the cleanest place to get your air.
Yeah, so you don't know where it's coming from with exhaust, because you just put the house under negative pressure and the air comes in through the leaks. A building is a three-dimensional network of airflow pathways, and they're connecting all kinds of things. So
Right.
in ASHRAE 62.2's mind and the code's mind right now, it doesn't matter what strategy you use, exhaust only, supply only, or balanced, you have to do the same rate. And what Joe's trying to get them to recognize is the difference between those two, and say, if you put in a balanced system and the ventilation air is distributed through the house and you get good mixing in the house with that air, then you should be able to put in a lower rate, use a lower rate. And
so balanced and distributed and mixed is obviously better.
Yep.
It's sort of surprising that you don't get credit for that.
Yeah, and real briefly, balanced means that you're bringing in and exhausting from the house equal amounts of air, so that you ideally aren't changing the pressures on the house.
Okay. That's with an ERV then.
It could be with an ERV, an energy recovery ventilator, or an HRV, a heat recovery ventilator, or you can do balanced without recovery.
You could just
there's different ways of doing balanced.
So you would have an exhaust fan and a supply fan.
Yeah. So if you wanted to use your bath fans and range hood as part of your ventilation system, you could make it a balanced system by tying in some fans that are blowing air into the house
At the same rate.
And ideally at the same time.
It doesn't sound like a good idea.
Yeah.
It sounds like
it's
ERV
a little more
or HRV
complicated.
would be
If you have a box that has it all together in one place, that's the easiest way to do it.
Right. And you could actually balance, for an ideal context, in humid climates, you would balance biasing toward bringing in slightly more than you're exhausting, so that you're pressurizing your house and pushing what we'd hope is a dry air mass through the walls, right?
Yep.
So balanced distributed, is there a standard for distributed, or what does that mean basically?
Well, Joe, a couple years ago, came out with a set of guidelines that he's been pushing to get adopted into ASHRAE 62.2 and the International Residential Code. And it includes basically the 2010 rates, the 7.5 CFM per person and 1 CFM per 100 square feet, with a table of multipliers for determining what the final rate should be. So you start with the 2010 ASHRAE 62.2 rate, and
which would be 100 and not
so
105.
so
that would be 55 in the example we get. 55.
Yeah. So
CFM.
let's say that that example of the 2,500 square foot
three
bedroom house. If you put in, if you put in a balanced and distributed system, you would put in the the rate given by the 2010 version of ASHRAE 62.2. So it would be 55 CFM. If you put in a system that's not balanced, but the ventilation air is distributed through the house, so this would be like a supply only where you have a duct go into like an air cycle type of system, central fan integrated supply.
Yes.
The duct goes to the air handler. When the air handler is running, it pulls outdoor air in and mixes it a little bit and distributes it through the house. So that would not be balanced, but it would be distributed. And since it's not balanced, you would have to add a little bit more according to Joe's standard, and you would increase the rate by 25%. So the multiplier is 1.25. So it'd be 55 CFM times 1.25.
That is 69 CFM. So now, and that's continuous again.
If the ventilation system is balanced but not distributed, it would be the same multiplier, 1.25. If the ventilation system is neither balanced nor distributed, then the multiplier is 1.5. So it'd be 55 times 1.5. And,
yeah, now you're at 110 again.
I'm
sorry.
I think that's about 80 or so.
Times 1.5. 82, yeah.
82 CFM. And then he's got one other multiplier in there. He says with all those multipliers, 1.0, 1.25, or 1.5, you can reduce them by 0.25, a factor of 0.25, if the air is mixed. So he talks about a recirculation rate of 70%, and so you get good mixing of the air in the building.
Mm-hmm.
And then you can reduce the whatever rate you have from those multipliers by 25%. So if you have balanced, distributed, and mixed, instead of 55 CFM, it would be 41 CFM.
So he actually gives you a way to go under it.
Yeah.
Mm-hmm.
Yeah.
So anywhere, according to, that was BSCO1, it's anywhere from 40 CFM to 80 CFM, where 62.2 is saying 55, but now 62.2 has said 105. You staying with these numbers, audience, out there?
Yeah, it gets a little tricky to figure this out. But remember, we're basing this on ASHRAE 62.2, which is a standard that is evolving, like all standards do. Every 3 years they come out with an update.
Mm-hmm.
The 2010 version is, in a lot of people's mind, the ideal version because it's a good amount of ventilation. It seems to do the trick for a lot of places. And the 2013 version upped that significantly. So,
does anybody know of any like epidemiological studies where we've looked at health outcomes from different rates or hospitals? I don't know. Hospitals actually have a lot more information.
As far as I know, there are no large epidemiological studies showing this kind of stuff. There are plenty of ventilation studies. But they're not really epidemiological studies. They look at different things. They look at CO2 in a room and effective ventilation on that and stuff like that.
Because that's the goal, right? We want to make sure people stay healthy with their air, and getting fresh air in is obviously important, but the quantity it's still debating.
Yep.
It's an ongoing debate.
Yep.
And you and I are both going to be at ASHRAE this year. I think we're going to hear anything
Indeed.
exciting coming
Orlando.
When is that? January.
Is there any skiing near Orlando? Oh, man.
No, but I can
Why
go
don't they have
kite
this
surfing
conference in a cold place near mountains?
Because people might want to go kite surfing near the conference, of course.
Oh.
Hey, real quick, you guys, I did the math on Allison's 105 CFM from the 2013 standard. And if you take something like Atlanta design conditions, 105 CFM for a day, continuous now, so that's 105 cubic feet every minute for 60 minutes every hour for 24 hours a day. That is 151,000 cubic feet per day, and that is 10,000, I'm rounding off here, 10,000 pounds of air a day. And in that 10,000 pounds of air, 170 pounds of water a day. So that's 170 pints a day. So the dehumidifier becomes non-optional, in my opinion, at that point, when it's design condition. And, of course, I've exaggerated with those numbers because you're not going to have 24 hours a day of design condition. I mean, I guess you would assume it gets...
You're going to have
More humidity
Yeah,
at night? No, actually the humidity might stay the same. It's going to depend on weather. The temperature's going to go up and down.
Yeah, you're not going to be at design conditions very long.
Yeah. Well, yeah, I did. You're right. I did design conditions of 95 degrees and 30% relative humidity, which is similar to ours. But that's going to change for sure. Yeah.
What? 95? No. When
What are
we're
your
at 95 degrees, we have 95% relative humidity.
No, you don't.
Oh, wait, we're going into a different topic here.
We can look it up in Ashtray.
No, I'm kidding. Because a lot of people say stuff like that.
Yeah.
It was 90 degrees and 90% relative humidity. And, if you look up the dew point for that, it's no. I'm pretty sure you didn't have 90-90.
Yeah.
You
like
might
here in Austin.
might have had 80-80 on a really extreme day.
That would be
80% relative humidity and 80 degrees Fahrenheit.
Right. Yeah, if it's a lower temperature. When it gets up into the upper 90s or 100s, usually it's pretty humid.
Yeah.
30% relative humidity, something like that. 30 to 35.
You've never been to Hong Kong?
I have not been to Hong Kong. And we can look all that up, but that would just be more numbers for people to put in their heads. Okay, so...
What's wrong with putting numbers in your heads?
The great ventilation debate. It is certainly
maybe
a juicy debate and worth following. Do we have a sense of where it's going to go? Can you look into a crystal ball and say what's going to happen?
We'll see. I'll be at the ASHRAE 62.2 meeting next month. Gosh,
right.
about a month from now. A little over a month from now.
And you have a lot of good coverage of this in your blog.
I do.
Right? Yeah. Energy Vanguard blog. What
Look up, let's see. The first article I wrote on Joe Stiebrick's guidelines called Stiebrick Has New Ventilation Standard. Resistance May Not Be Futile.
There you go.
So if you just go online and search ventilation standard, Energy Vanguard, or probably if you just search ventilation standard Stiebrick or something like that, you'll find it.
Mm-hmm. So what if we should try to wrap up. We've talked a lot about ventilation and air, and I think I'd like to try to leave the audience with a wrap up, what do you really need to do? Right. So do you have a sense of that? Could you take an answer to that?
What you really need to do is make your house tight and then add some air. And you can also put some extra capacity in there so that you can turn it up when you need to, but have the ability to turn it down so that a lot of the times it's just running at a lower rate. Because most of the time you don't need that. I mean, if you notice a problem, then you can crank it up. If not, keep it lower.
Yeah, so you will notice when it gets very stuffy, and that's probably high CO2. But if we try to get specific, right, so I like the idea of variable ventilation rates. And if you guys go back to our podcast on, I think it was on comfort, health, and the basics of HVAC, we do talk about this idea of having variable ventilation rate. But you still need to pick a range of varying over what. So for this 2,500 square foot house, I guess we could say 105 would be the upper limit, and the lower limit, let's say half of 62 to 2010, maybe 25 or 30 CFM. So your range would be somewhere between 30 and 100 CFM. You think that's reasonable?
Yeah, I mean, a typical ERV or HRV will run at like 100 to 150 CFM.
Mm-hmm. So that plus a DHU, that amount of ventilation air would be ideal.
Yeah. So if you set up your a dehumidifier as a ventilating dehumidifier, then that's also bringing some in.
Mm-hmm. Mm-hmm. That's a great way to do it. Okay, everyone, and thank you, Allison, for being on the show.
Oh, you're welcome. It's been great.
Thank you, everyone, for listening.